Welcome back to another episode on Akyas Classes. In today's video, we'll be going to tackle another popular interview question on arrays, the maximum subarray. The problem is often solved using dynamic programming approach known as the cadence algorithm. So first we'll look at the formal definition of arrays and string, and then we'll move on to our problem overview. And once we go through that, we'll look at some approaches that we can use to find the solution, and then we'll look at what is optimal for solving this particular problem. And then we'll do the live coding stuff, and after that we'll just break down the entire stuff as we code. So basically, it's going to be a simple yet an interesting and full explanation on how you can possibly tackle these kind of questions. So without wasting our time, let's just start with the formal definition of array and string. So as you can see on your screen, this is the formal definition to arrays and string. So arrays and string are some of the most fundamental data structures in coding interviews. And array is a collection of items stored in a contiguous memory locations, and strings are essentially arrays of character. These structures are often used to solve problems that involve searching, sorting, and finding subarrays and or substrings. So basically, when you have an array, you have a, let's just say, a list of elements that are stored in a contiguous memory, right? Contiguous memory locations. You have this particular stuff located in this particular location, then you have something which is located in one index, two index, third index, minus one index, which is going to be the last one, zeroth index, which is the first. And this is how an array is formed. And a string is nothing but a collection of characters. Basically, the word array in itself is a string. The word introduction in itself is a string, because it is an array of characters. So basically, this is the formal definition of arrays and string. So now let's just move on to our problem overview, and let's just understand what problem we are going to solve today. So the problem statement: given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. So basically, we have an example up here where we have an input nums as an array where we have how many 9 elements, and then we have an output is 6, for example. And what do we want our output to be like is let's just say that we have 9 elements, and we have to pick a certain specific elements out of this array and form a subarray whose sum is going to be our output, which in our case is 6. So I have to take out certain specific elements. So for example, if I were to take 4, minus 1, 2 and 1, and if I were to sum all of these elements, my answer is going to be 6, which I want as an output, right? Which I have been given as an output. So in this case, we have both input and output, and I have to just find the path. So my path is going to be the subarray, right? So let's just look at the approach that we can take to solve this particular problem. So the approaches are pretty simple. We have brute force approach, and then we have the optimized approach, which is cadence. So the brute force approach, basically it checks every pair of the element, right? Because that's what the brute force does. The brute force way is to generate all possible subarrays and calculate their sum. So we can keep track of the maximum sum we find, and we can just check whether which outcome gives us as the answer 6. But the problem is that the time complexity here is O n square, and because we are checking all the subarrays, and it takes a lot of time if we are working with a large group of data. So we're not going to particularly perform this right now. We are going to work with the optimized approach. But if you want to try the brute force approach, then I'm going to show you the code. You can just pause the screen and can look for the code, and you can just do on your laptop or something like that, or you can take a screenshot of it so you can work it with later on. So here's the code, you can see it. So this is the way you do the max subarray using the brute force approach, which is not optimal. This approach works but is not efficient for large arrays. So let's move on to the optimized one. So the optimized one is cadence algorithm. So let's dive into the cadence algorithm. This algorithm allows us to solve problems in ON time by iterating through the array just once. Here's the idea behind it. So we maintain two variables. The first is the current sum, and then there is the max sum. So the current sum tracks the sum of current subarrays we are considering. Current subarray we are considering, not arrays. Then we have the max sum. Keep tracks of the maximum sum we have encountered so far. And at each step we make a choice. Either continue adding the current element to the existing subarray or start a new subarray with the current element. That's how we do it. So the basic step is going to be three-step process. Initialize max sum to a very small value, example infinity. Then we'll initialize the current sum to 0 and then we iterate through the array. For each element, num, calculate whether to include it into the existing subarray or start fresh. And once you're done with that, update the max sum if current sum becomes larger than the max sum. That's the entire process of it, right? So let's just do the live coding where you will start to actually understand what I've just said in the entire pseudocode language. The first thing we do is create an array, right? The input array. So the input array is going to be nums, where we'll put on the elements that we have decided in the example one. So there are going to be 9 elements, which is going to be -2, 1, -3, 4, -1, 2, 1, -5, and 4. I have a good memory. Then we'll create a function calling it the max subarray, where we'll pass on an argument as our formal arguments, nums, right? And then we'll just start with the first element, which is going to be max sum, and it is going to be nums of 0th index just because it is the first element. Then we'll create a current sum to 0, right? Because we have started with the first element and our current sum is simply 0. Now we'll start to iterate through the array, right, using the for loop and check whether the current sum is smaller than the 0 or not. And if it is going on the negative side, then reset if the sum goes negative, right? That's what our approach is going to be, simply. Then once done with that, we'll add the current element to the sum, right? We'll iterate through the array and add the current element to the sum, and then we'll just track the maximum sum and return the sum. That's it. That's the entire process of just creating this function. That's it. That's all of it. It's not as complicated as it seems or as it sounds. It's pretty much simple, right? So we'll create a variable result and then print the result. So that is it for today's problem. We went over the maximum subarray problem and discussed both the brute force approach and cadence algorithm, which solves it efficiently. So these types of dynamic programming problems come up often in the interviews, so make sure you practice more variations. You can just go on to any of the websites where you can find these kinds of problems. Like you can just go and search for the common interview questions in DSA or something like that. You can find a lot of answers out there. So next time we'll explore another array related questions, but for now practice cadence algorithm and try solving more problems like maximum product subarray or something like that. So thanks for watching. If you found this video helpful, then make sure to hit the like button and subscribe for our classes, and let me know in the comments if you have any kinds of questions or something like that. So happy coding.